Hi everybody, here's that extra video about testing philosophy that I promised. So at the beginning of the regular lecture, I mentioned the idea of an autograder. It's a tool, a piece of code, that looks at your code and it says whether it's right or not. So now that we've seen some of the libraries out there that exist for testing, I'll mention that behind the scenes, we're using those tools. We use truth, just like we've learned today. We also use JUnit, which is one level of abstraction below truth, and then another library I put together called JH61B, that is used for various utility purposes. So these three libraries together provide a set of abstractions that we use to write the tests for your code. Now the downsides of the existence of the Autograder is, well, one, they don't exist in the real world. So if we get you used to the idea that there's a magic oracle that can look at your code, then you're not prepared to build your own projects. The other reason that it's a big deal, even within the context of the class itself, is that it's a very slow workflow. What do I mean by that? Well, the most extreme version of the student workflow, the most naive student workflow, is what I call Autograder-driven development. And this is the worst way to approach programming in 61B. So you write your entire program, you send it to the Autograder, and you get a bunch of errors. We've already tried to mitigate this by giving you local tests for the projects, but I know it's still tempting. Maybe you're in the habit. So then what you do is, until you're correct, you repeat the following. You run the Autograder, you add print statements to find the bug and get something like this, right? Like maybe that's the output of Gradescope, and then you make changes to the code to try to fix the bug. Now again, I'm hoping that the local tests have convinced you that even on Project Zero, this isn't the way to go, but this is a workflow to be very careful about avoiding. Now one thing about the tests we provided for Project Zero is that you didn't write them, and you weren't necessarily super familiar with the debugger, so being able to more correctly approach the debugging process was hard, yes, but at least this, I just want to set this as like the thing you should not do, not in this class, not in any other class. Okay? This workflow is very slow and it is very unsafe. Okay? The reason it's unsafe is it's just going to lead you down a labyrinth. You're going to be chasing bugs forever. It's going to take you so much time. It's bad use of your time. Okay? I do want to note that I don't think print statements are bad for debugging. They're not inherently evil. I just think they're a weak tool. They're easy to use, which is great. But it's the other tools we've talked about in class, like the debugger and having nice small unit tests that really help. So the other tool we have for correctness are unit tests, which we've seen today. The idea is we write tests for every unit, and all the libraries we've talked about, truth, AssertJ, JUnit, make it easy to do. It's like only a few lines of code. So there's some upfront investment to write these green blocks, but it saves you time in the long run. I really, really think so. When I write real code, I write these all the time. It's super useful for all the reasons described in the regular lecture. Now I mentioned that in the real world, there's an even more extreme version of unit testing called test-driven development. And you could think of it as the opposite of Autograder-driven development. In this approach, you start by identifying a feature, right? Like, I want to create an add first method for my data structure, or I want to create a letter frequency guesser or whatever. You identify some concrete feature, and then you write a unit test for that feature if possible. Some features are impossible to unit test alone, like for example, add first. Like you can't somehow, depending on what you're building, you might not have any way to interrogate the data structure if you can only add to it, right? Then you run the test, and it should fail. You get a red. So if you have a problem you can actually do this for, you create the test, you run it, it fails, we're in the red zone. And now we basically turned the programming into a game, okay? What do we do next? We write code that passes the test. That's the green step, okay? Now if you're red-green colorblind, sorry, maybe these look a little different, but at least I have the words here. Anyway, we write the code that passes the test, and we end up in this green zone. And in the real-world programming practice, what we know now is that the implementation is certifiably good. Look, we're passing all our tests, right? This is what it might look like in an IDE. All the tests passing. It feels good. Got a green bar. Now, the optional step, step 3, is that later you can improve the quality of your code. Like, I don't like the way it was implemented. It's too slow, or it's too awkward, or the code looks too complicated. It's hard to read. And what's nice about it is that if you make those changes and you end back in the red zone, well, then you can keep going and go back to the green zone again, right? So it makes the whole thing into a game that if you try to improve your code but break it in the process, you get caught immediately and you can fix it, okay? Now, it's not required in 61B that you do this. You might hate the idea of always writing tests first, but you can try it if you want, right? So if you, and even if, but I would say this actually, even if you don't use test first, this formal test-driven development process, I'll say that testing is a very good idea in general. Now, it takes some wisdom to figure out how much testing is too much, but you'll feel it out. And I think as students, you'll probably tend to err on the side of not testing enough. There's an interesting perspective on this blog post here that you might find fun to read. Red shirt, red, green, refactor. I'll leave it there if you want to read. Okay. So basically, there's two opposing workflows. There's TDD on the right, and there's ADD, Autograder driven development, or Autograder with print statements driven development. And what's best for you is probably somewhere in the middle, but please avoid this kind of programming in our course. It's just, you want to be more disciplined. Okay. Now, the last thing I want to mention before I go is actually another type of testing, which is known as integration testing. And this is tests that cover the interaction of all of your units or many of your units at once. And this is something like we saw in Project Zero, where we had those tests that were called integration tests. They were just more comprehensive. They fed real data into the methods and made sure that everything was working properly, that all the output of the game, so to speak, was correct. Now, you didn't write the code that actually did the game, so that part of the testing was probably totally invisible to you, but the idea was a test that did everything all at once. Now, unit testing is great for building basic confidence, but it's not enough to tell that necessarily the whole system is working as a cohesive thing, and that's why integration tests exist. Now, we're not going to have you build these full-scale integration tests in our class. They are often done with some kind of automatic software. There's actually a whole ecosystem of tools out there for integration testing. You can do it with Truth and JUnit, but people also write their own custom tools. It's been done in 61B in the past, where there's some kind of specialized script, maybe in Python or something, that evaluates your Java code on a bunch of different inputs, right? And it ends up being a lot of work, and it's just not really worth it for the scale of programs that we're doing in our class. And of course, integration tests can also be done, thank you stock photo, manually by, say, spinning up a website and poking at it and seeing if it breaks. That's a form of integration testing. Okay, that said, we're done for today. I hope you enjoyed your bonus video, and I'll see you next time.